As these magnetic fields become increasingly complex and tangled, they create immense pressure. Eventually, this magnetic energy can no longer be contained. When it's released, it launches a phenomenon known as a coronal mass ejection, CME, a vast cloud of charged particles and magnetic fields blasted into space. If Earth lies in the path of this CME, the result is a geomagnetic storm that can severely impact satellites, GPS systems, aviation, and even the power grid on the ground. At Infinity Beyond, we take a closer look at these invisible threats. The Earth's magnetic field, our first line of defense, usually absorbs or redirects most of the solar wind. But during strong solar events, even this protective shield can be compromised. These particles slam into the atmosphere, creating breathtaking auroras across the sky, yes, but also straining communication systems and sensitive electrical infrastructure. This interaction between solar wind and Earth's magnetosphere is known as space weather. On a normal day, space weather is mild. But during peaks in solar activity, such as during solar maximum, the frequency and intensity of flares and CMEs increase dramatically. We're entering just such a phase now, solar cycle 25, which is proving to be more active than initially predicted. Unlike hurricanes or earthquakes, solar storms offer almost no visible warning signs to the average person. There's no howling wind, no shaking ground, only invisible particles racing through space at thousands of kilometers per second, heading straight toward Earth. So, as we continue to rely more heavily on satellites, internet infrastructure, and global connectivity, we also become increasingly vulnerable to the sun's temperamental bursts. That's why understanding the mechanics of the sun's activity and learning how to predict and mitigate the risks is no longer a distant scientific curiosity. It's an urgent necessity. At Infinity Beyond, we aim to demystify this cosmic challenge. In the next chapter, we'll journey back to 1859 to explore the Carrington event, history's most powerful solar storm, and ask the question, what if it happened again today? The last time a truly powerful solar wind hurricane slammed into Earth was on September 1st, 1859, an event now famously known as the Carrington event. That day began like any other, but out on the surface of the sun, something enormous had started to brew. A towering arc of solar plasma surged upward, rapidly expanding and glowing with intensity. This explosion, many times the size of Earth, was no ordinary flare. It was a massive coronal mass ejection, CME, and it was pointed directly at our planet. Within just 18 hours, an astonishingly fast journey for solar particles traveling 150 million kilometers, the CME reached Earth, igniting a chain reaction never before witnessed in modern human history. The skies lit up with brilliant auroras, not just in the polar regions, but as far south as Cuba, Mexico, and even Jamaica. People in New York and Boston thought it was morning and rose early, confused by the eerie glow filling the night. For those living in the 19th century, this was both mesmerizing and terrifying. Imagine seeing the sky pulse in green, red, and purple bands, without having any scientific understanding of why it was happening. Many thought it was the end of the world, but the visual display was just the beginning. Back then, the most advanced technology was the telegraph, the backbone of long-distance communication. As the storm struck, telegraph wires across continents sparked and caught fire. Operators reported receiving electric shocks, some strong enough to knock people unconscious. Telegraph systems went haywire. Some continued operating even after being disconnected from their power sources, seemingly powered by the solar storm itself. Entire networks went down. Communication collapsed. And yet, this was 1859, a time before power grids, satellites, aviation, or internet systems. The technology was minimal, and even so, the disruption was severe. Today, a Carrington-level event would have catastrophic consequences. At Infinity Beyond, we often ask a simple question: what if this happened now? Consider this. Our world is completely dependent on electronic infrastructure. From mobile communication and GPS navigation to air traffic control and banking systems, everything is interlinked and vulnerable. A CME of similar intensity today would overload transformers, knock out satellites, fry GPS systems, and possibly cause a global blackout. Governments and space agencies like NASA are aware of this threat. In fact, they've classified space weather as one of the greatest risks to national infrastructure. But the truth is, the Earth has had close calls since 1859. In 1921, the Great Railroad Storm disrupted train networks. In 1989, a weaker CME blacked out the entire province of Quebec, Canada, in less than 90 seconds. And in 2012, a storm narrowly missed Earth by just 9 days, an event that could have caused trillions in damages if it had struck. These aren't science fiction scenarios. These are real events, documented and studied. The Carrington event was a wake-up call, a silent warning from our sun that despite its warm glow, it holds the power to erase centuries of human progress in a matter of hours. At Infinity Beyond, we dive deep into these forgotten cosmic warnings. And in the next segment, we'll revisit some of those near misses, especially the terrifying solar storm of July 23, 2012, when Earth dodged devastation by a mere twist of timing. Because the truth is unsettling. We're overdue. And next time, we might not be so lucky. July 23, 2012. While most of the world went about its day unaware, our solar system narrowly escaped what could have been a cataclysm. On this date, the Sun unleashed two massive coronal mass ejection, CMEs, enormous clouds of electrified plasma that tore through space at blistering speeds. Had Earth been in the line of fire just 9 days earlier, the result could have been devastating. According to NASA, it would have been the modern-day equivalent of the Carrington event, but with consequences on a global scale. At Infinity Beyond, we ask, what if we hadn't been lucky? The 2012 storm was composed of two CME waves that collided shortly after being ejected from the solar surface, creating a supercharged storm front. Traveling at more than 3,000 kilometers per second, it reached Earth's orbital path in under 19 hours. Thankfully, Earth had already moved ahead in its orbit, and the storm missed us by a cosmic sliver. But if that event had struck Earth directly, the aftermath would have been catastrophic. Satellites in orbit would have failed. GPS systems used for aviation, military targeting, navigation, and finance would have gone offline. Internet backbones, including underwater communication cables, would have been severely affected. Even in the ocean depths, the surge of electromagnetic radiation could corrupt fiber optic repeaters essential for transcontinental data transmission. Entire nations would have suffered a communication blackout. On land, electrical grids would have faced an assault of geomagnetically induced currents, DC currents surging through infrastructure designed only for AC. Transformers, the heart of power delivery, would overheat, melt, or explode. Recovery could take months, even years, as transformers are expensive and complex to replace.